space exploration. International Space Station, as I had indicated, has been very exciting the last few periods. We've celebrated our 10-year anniversary, and that includes 8 years of fully staffed station. We've been at a 3-person crew, and this summer we'll be going to 6-person crew, bringing us up to be able to pick up on the full science. And I say full science, but we have been actually exceeding our marks in getting the science research done during our construction phase. So back in November, we celebrated the 10-year anniversary. And of course, with this launch, thanks to John, we have our S6, our last component of the U.S. operations segment. And that element brings us up to full power. So we should have 30 kilowatts for science, 120 kilowatts capability in totality. And as indicated, this summer we get the 6-person crew. We'll also be having the exposed facility come in for JAXA. Columbus has been there for a while. The Kibo module for JAXA has been there. And so that adds to the U.S. lab destiny, and we're complete with our science as we continue this summer. Now let me talk a little bit about the science that has already been going on. We've reached into not only the exploration elements, looking at the human physiology and some of the experiments that are going on there, but also the cellular level. Working with in 06 and 08, and again this particular mission, we've been working with the salmonella, looking for a virus associated with that, and that's through NASA cooperation with academia, Arizona State, and as well as some of the smaller, in fact, Colorado-based BioServe helps out with that perspective. And that's looking at viruses through the National Institute of Health. And some of the work there has enabled effectively, well, like most science, from hypothesis to experiment. And the hypothesis here is that the space environment, zero gravity, would have an effect on viruses and their virulence. In fact, they do. And those series of experiments would allow them to make some modifications at the gene level, and then get those back and do the analysis associated with bringing in what could possibly be a virus for, a vaccine for multiple viruses. So on the viruses perspective, also in the cellular level from plants, looking at biofuels and how would gravity affect that and be able to have replication. Could go into some of the elements of stem cell as well as the biofuels. So a lot going on, a lot of capabilities looking at the actual structural cells, and enabling us to look and say, how do the backbone of the cell, how is that changed? And those elements then allow you to evaluate things by changing that gravity. So it is a tremendous opportunity to use the national lab that's there. And our international partners are taking advantage of that. And we're just now beginning to see the full potential of the International Space Station. So part of that, because John gets us there safely.
Pleasure to get together and talk about our team. As you know, we just finished the STS-119 mission, and it was as near flawless as you can expect any shuttle mission to be. And so that was the 125th mission, and I guess the 28th mission to Space Station, and the 36th mission of Discovery, which leaves our vehicles about 1/3 through their structural design life. So they're operating flawlessly and magnificently. And of course, as we look into the future, we've got an immense challenge ahead of us. Our team is focused. We've got 9 flights scheduled on the manifest. Right now, scheduled to be done in 2010, and the team is really committed to this program, and they're committed to the human spaceflight endeavor. And really, when we look at the impact on our team, we're looking at 2 gaps. And of course, the first gap is from shuttle land to a replacement vehicle, and Jim will talk a little bit about that effort. And really what we're focusing on there is our ability to continue the science on Space Station, which really has established itself as the national lab without compare. And Joy talked a little bit about the science that they're doing on the station now and some of the work that they've got scheduled. The other gap that our folks are really interested in because of the impact on them is the gap between shuttle and the award of Altair and Ares 5. And the reason that gap has an impact on our team is when you look across our team and the skill sets that we have on this team, we really have a nice match to be able to move some of that expertise over into Altair and Ares 5. We've got the resources in the team and the infrastructure, I think, to really jump in and do a great job for NASA. And so the ability to compete for that work and gracefully move that workforce over is something that would really be beneficial to our team. And so those are the two gaps that we're really focused on in the near term. But as you saw in this mission, I think really the focus over the next year and a half at a minimum of this team is going to be to make sure that we continue to execute these missions flawlessly. And I think our team is well positioned to do that in the community. And with that, I'll turn.
Be meeting with some of you in the last couple of years. I've met many of you in the room. As a quick reminder of what Boeing's doing on the Ares 1 program, which is an element of Constellation, we're building the production system and assisting NASA with the design for the upper stage and the upper stage instrument unit, which carries the avionics and the guidance that touches all the other elements. There are two other elements on the rocket, an upgraded engine, J2X, you're probably familiar with. It's an upgrade from an engine that flew on Apollo, and there's going to be an upgrade to the first stage. The boosters that fly on the shuttle today, our first stage would be an upgraded version of that. So the part that Boeing's working on, primarily in Huntsville, Alabama, but in several other places as well, is the new design stuff, with NASA leading the design and us assisting and us having full supply chain and production responsibility. Where we are today is about 9 months past preliminary design review at the rocket level. And rather than go into too much lingo, I suspect you understand it. We're going from concept and architecture and sort of a modeled rocket to creating detail parts. So we're actually creating the designs, going through lots of iterative, do these things fit together? Does the integrated rocket work together? Frankly, it's a real exciting time. And of course, all that happens in a phased way. You start with your long lead primary structure, and you flesh out the things that have shorter lead time and you want flexibility later in the design project. And it's all going very well, I'm sure. And at any point in a program like this, you've all been around them, you can find 4 or 5 issues and 4 or 5 real positive surprises that you didn't expect to go so well. And I would characterize where we are as just about there. One thing I would like to point out is we are in the details in some of the long lead components to the point that we are activating our supply chain. We've selected Ball Aerospace for the flight computer. For this rocket, we've selected ATK for a set of Ullage settling motors that allow us to get the propellant right during the stage separation from first to second stage. Ensign Bickford will be building pyrotechnics for us to make sure the separation system happens, and there are many more imminent, but to give you a flavor or a feel for where we are in the program, we're bringing partners aboard and activating